All right, let's talk about one of the most powerful but kind of underrated tools in all of science, dimensional analysis. You can think of it as the secret grammar of the universe. It's this fundamental set of rules that everything has to follow, from your physics homework all the way to building spaceships. Let's get into it. So just imagine this for a second. You're on a team that just launched a $125 million orbiter to Mars, but then it just vanishes. Why? Because of a tiny mix-up in the software between metric and imperial units. Now, this isn't a hypothetical. This actually happened to NASA. So how do you do a basic sanity check to make sure your formulas aren't just complete gibberish and prevent these massive, catastrophic errors? Well, the answer is that there's this hidden language, a strict set of rules that every single valid physical equation has to obey. It doesn't matter if you're using meters or feet, kilograms or pounds, the underlying structure, the grammar, has to be consistent. And figuring out that structure, that's what dimensional analysis is all about. To really get this language, we first need to learn its alphabet. And you might be surprised to find out that pretty much every physical thing we can measure, from the speed of a car to the force of gravity, is built from just a few core ingredients. The three big ones, the core dimensions for most of what we do, are mass, which we'll represent with a capital M, lengths with a capital L, and time with a capital T. That's it. These are our fundamental building blocks. Pretty much everything else is just some combination of these three. So this is how we start building words with our new alphabet. Think about speed. What is it? It's just a length you travel over a certain amount of time, right? So its dimension is length divided by time, or LT-1. Or what about force? Well, you might remember force is mass times acceleration. When you break that all the way down, you get mLT-2. All of a sudden, these complex ideas have a simple universal code. Okay, so we have our alphabet, we have some words. Now for the really cool part. Let's actually use them. The first and maybe the most powerful application of this whole idea is using it as an instant equation checker. It's basically spell check for physics. We're going to start with an equation that everybody knows, just so you can see how this works. We all get intuitively that speed is the distance you cover divided by the time it took. But the real question is, does it pass the dimensional sanity check? Let's find out. So first step is simple. We just replace each piece of the equation with its dimensional symbol. On the left, speed becomes LT-1. On the right, distance is just a length, so L, and time is, well, time, so T. Now for a little algebra. Don't worry, it's easy. Dividing by T is the exact same thing as multiplying by T to the power of -1. So the right side, L divided by T, simplifies down to LT to the power of -1. And, would you look at that, the dimensions on both sides of the equal sign are exactly the same. And this is the whole point, because both sides balance out. The equation is dimensionally correct. It actually makes physical sense. If we had ended up with something weird, like length equals time, we'd know immediately that our formula was totally wrong, and we wouldn't have had to do a single calculation. That is an incredibly powerful check. But it's not just for checking equations. Dimensional analysis is also your absolute best friend when it comes to converting units. A task that trips up everybody, from students to professional engineers, sometimes with, disastrous results. The process is actually super elegant. You just multiply by conversion factors, which are just really clever ways of writing the number 1, like 1,000 meters over 1 kilometer. You set it up so that the old units you want to get rid of, like kilometers, cancel out, and the new units you want, like meters, are left behind. The dimensions are your guide, making sure you never accidentally divide when you were supposed to multiply. Now, as amazing as this tool is, it's not magic. It's really important to understand not just what it can do, but also what it can't do. It has some very clear boundaries. And here's the biggest limitation. Dimensional analysis is great at confirming that the types of quantities in your equation make sense, but it is completely blind to any numbers that don't have dimensions, like constants. For instance, the real formula for kinetic energy is 1/2 mv squared. But a formula like 7 mv squared is dimensionally identical. This tool can't tell the difference between the 1/2 and the 7. It's a consistency check, not a numerical accuracy check. So, what are the big takeaways here? First, everything physical can be broken down into mass, length, and time. Second, you can use this to do a quick sanity check on your equations. Third, it's a super reliable way to convert units. And finally, just remember, it's checking for consistency, not whether your numbers are perfect.
And that kind of leaves us with one final big thought. This isn't just about getting a better grade on a physics test. If our fundamental understanding of dimensions and units is even a little bit off, then every single calculation, every experiment, every theory we build on top of that is resting on a shaky foundation. So, why is this simple grammar check the absolute bedrock of our ability to understand the universe at all? It's something to think about.